Buridan's ass. This paradox describes a hypothetical situation where a donkey ass that is both hungry and thirsty is placed exactly halfway between a stack of hay and pail of water. Because the donkey is equally thirsty and hungry, it is stuck frozen between the two, unable to choose. The donkey eventually dies from both starvation and dehydration. The Chinese room. The Chinese room argument holds that a computer executing a program cannot have a mind, understanding, or consciousness, regardless of how intelligently or human-like the program may make the computer behave. Imagine you're placed in a room with a small gap at the bottom of a wall. On the other side of the room is a Chinese person. The Chinese person slips you a note written in Chinese, and you have to answer using the guidelines written for you. You slip the letter back and forth, simulating a conversation. To the Chinese person, you're someone who speaks Chinese as well. But in reality, you don't actually understand Chinese, you're just following a set of pre-written rules. Schrödinger's cat. A cat is placed in a sealed box with a radioactive atom. If the atom decays, it triggers a mechanism that kills the cat. If it doesn't decay, the cat remains alive. According to quantum mechanics, before we observe the system, the cat is in a superposition of being both dead and alive. This raises questions about the role of observation in determining reality. Newcomb's paradox. You're faced with two boxes, one transparent with $1,000 and one opaque that either contains $1 million or nothing. A superintelligent computer has predicted whether you will choose to take both boxes or just the opaque one. If the being predicts you'll take both boxes, the opaque box will be empty. If the being predicts you'll take only the opaque box, it will contain $1 million. The paradox raises questions about the nature of rationality, free will, and prediction. People who'd take only the second box argue that the supercomputer, who hadn't been wrong before, would have certainly predicted it, and you are thus leaving with $1 million. People who'd take both boxes argue that no matter whether the second box contains money or not, you will always have $1,000 more by picking both. The ship of Theseus. If a ship is gradually replaced piece by piece until none of the original parts remain, is it still the same ship? This raises questions about what makes something the same over time and how we understand personal identity, objects, and continuity. Beetle in a box. Imagine that each person has a box with a beetle in it. The box is opaque, so no one can see inside anyone else's box, and each person can only see the beetle inside their own box. Everyone calls what's in their box a beetle, but no one can compare their beetle to anyone else's. Each person only knows the beetle in their own box, and they may describe it in various ways. The core question it poses is, if each person's beetle is locked in their own private box, how can they be sure they are all talking about the same thing when they use the same word, like beetle? The trolley problem. Traditionally, the problem goes as such. You notice 5 individuals tied to some train trolley tracks. A train is coming right at them, and you do not have the ability to untie them in time. However, you could pull a lever diverting the train to another set of tracks, but in so doing, you would kill an innocent bystander who is tied to those tracks. The problem raises questions about utilitarianism, maximizing overall good versus deontological ethics, following moral rules. A simple surgery. You are a doctor in the future. A patient comes into your office with several symptoms, and you quickly identify their ailment. A failing heart. They could potentially die without treatment. In fact, they pass out in your office. Luckily, you know all that is required is a simple surgery in which you can give your patient a synthetic heart, and they will be good as new. Yet, as you are preparing to take the patient into surgery, A small medical card falls out of their pocket, indicating that for religious reasons, they do not want any synthetic organs. If you do not install the synthetic heart, the patient could die. But if you do, you will be violating the patient's wishes. Another variation of this experiment is one where the patient is replaced with a child. The child needs the synthetic heart, but the parents refuse to let you perform the surgery for religious reasons. Imagine you have the legal authority to carry out the surgery. Will you do it? The drowning child. Imagine you are wearing a $1,000 suit and see a child drowning in the ocean and being pulled away by the currents. You don't have time to take off his suit and save the child. Are you morally obligated to jump in the ocean and ruin your suit to save the drowning child? Now, if you answered yes to that first question, consider this. A person is up late watching television, and an ad comes on stating that with a $1,000 donation, you can save a child's life in a poverty-stricken village recently ravaged by floods. The person researches the charity, and it appears to be legit. Is this person morally obligated to donate $1,000 to save the child in a poverty-stricken village if they have the money to do so? If not, how are the two examples different? Thompson's violinist. You wake up in the morning and find yourself back-to-back in bed with an unconscious violinist. A famous unconscious violinist. He has been found to have a fatal kidney ailment, and the Society of Music Lovers has canvassed all the available medical records and found that you alone have the right blood type to help. They have therefore kidnapped you, and last night the violinist's circulatory system was plugged into yours, so that your kidneys can be used to extract poisons from his blood as well as your own. If he is unplugged from you now, he will die. But in 9 months, he will have recovered from his ailment and can safely be unplugged from you. Do you have a moral obligation to keep the musician alive? This is a popular defense of abortion. Wax argument. Imagine you have a wax candle in your hands. Assess its properties, its color, its smell, its size, and its texture. Suppose you then heat the wax, burning it over a fire. It loses all of its previous properties. It becomes a liquid. Its shape changes, its smell disappears, and its texture becomes different. What is the wax now? In other words, even though the wax has changed completely in its physical properties, it is still recognized as the same wax. But how can we know it is the same wax? Rationally, we still know it's the same wax, but our senses don't tell us that. Mary's room. Mary is a neuroscientist who has spent her life studying color vision. She knows everything there is to know about the science of color, the wavelengths of light, how the brain processes color, the physical properties of the eye, etc. However, Mary has been confined to a black and white room her entire life, meaning she has never experienced color herself. Now imagine she was let out of the black and white room and experiences color for the first time. Say, she picks up a red apple. Does she learn anything new by experiencing the color, even though she already knew all there was to know about it?